Hey everyone, this is lesson 3-2 in which you are going to determine unit rates with ratios of fractions. This lesson begins on page 169, so you'll need to go there into your binder pages and get ready for the lesson. We are going to skip over the solve and discuss it today for the purposes of working through the examples and the try-its and a couple of practice questions before you get started on your assignment today. So you can go ahead and turn to page 170 and we'll begin at example 1. Example 1, we are going to find a unit rate involving unit fractions. And you may remember from our first lesson in this topic that finding a unit rate is finding an amount out of one of the other unit. So we're also going to be using unit fractions, which shows us that we have a numerator of 1. So a unit rate and a unit fraction actually have a 1 in opposite positions. A unit rate has a 1 in the denominator of that ratio, and a unit fraction has a 1 in the numerator of that fraction. So here in this problem we have Sergio. He is training for a triathlon and his target speed is 25 miles per hour. Did he achieve his target speed for the first 7 miles of his race? So our reasoning here is that we're going to be using the unit rate to describe Sergio's cycling speed. And you notice that the information that you need is over here in the picture, and that Sergio has traveled a total of 7 miles and he did so in 15 minutes time. So we're going to use that information here to solve the problem, and they've done this for us basically in 2 steps. In the first step, you know that 15 minutes is equivalent to a quarter of an hour. So what we're doing is we're using that 1/4 hour as our part of our rate, where we're going to find out how far he traveled in 1 hour's time. So the diagram here shows you that rate of 7 miles that Sergio traveled in 1/4 of an hour's time. And then you'll notice in order to get to a full hour that you need to have 4/4. So 1/4 times 4 is 4/4. Okay. And whatever you do to one part of a rate, you have to do the same to the other. So we also have to multiply the 7 miles that he traveled by 4 in order to see how far he went in that 1 hour's time. And that would be 28 miles. Okay, and again, the 1 stands for 1 hour. So you can also see over here on the table of equivalent ratios that you're doing the same thing. So here is our initial speed. Okay, he traveled 7 miles in a quarter of an hour, and you're multiplying both parts of that rate by 4 in order to see how far he goes in 1 hour. So this piece right here that says 28 miles in 1 hour is your unit rate. The unit fraction in this problem is the 1/4. Okay. So Sergio bikes 28 miles in 1 hour, or per hour, so he has achieved and actually exceeded his target speed. All right, now let's take a look at the try-it. So Sergio increases his target speed to 30 miles an hour. In other words, that's how fast he wants to go now. How many more miles does Sergio need to ride in 1/4 of an hour to achieve this target speed? And you can see here that they have drawn a table to try and guide us in this work. So what we're trying to do here is to see how we can hit this target speed of 30 miles in 1 hour by working backwards. So if I divide by 4 to get back from 1 hour to the 1/4 of an hour, then I also need to divide by 4 in the numerator number. So that means Sergio must ride 7 5/10 miles in a quarter hour to achieve his new target speed. Since he already was riding 7 miles in 1/4 of an hour, then that means he needs to ride an additional half mile or 5/10 of a mile per quarter hour to achieve that target speed. Take a moment to read through example 2. Pause the video while you do that and see if you can follow the work that they have done in order to solve this problem. We'll come back in just a minute and I'll explain what they did. What I want you to notice, especially in this example and in other problems that involve fractions, is that in order to get a unit rate here, looking at the fraction that is in the denominator, which is 2/3, you actually have to use multiplication in this case in order to get that 1/2 in the denominator. And in order to make that denominator 1/2, you have to multiply by that reciprocal fraction, 3/2, in both the numerator and denominator in order to get a denominator equal to 1/2. So when you do 2/3 times the 3/2, you actually end up with 6/6, which is equivalent to 1/2. But again, whatever you do to the bottom of that ratio, you have to do to the top. So when you multiply the 12,000 times 3/2, and I'll do that up here. Remember, whole numbers have a denominator of 1. You do the 12,000 times 3, and you get 36,000 over 1 times 2, which is 2, and then you can simplify that to 18,000 over 1 if you're looking for a unit rate. Okay, and that's exactly what they did right here. Then they went ahead and said, well, the lawn is 36,000 square feet, so, and you can see up here at the top where we already did that, I multiplied both of those parts by 2 to see that in order to mow all 36,000 feet, it takes her 2 hours to do that. Okay, another way to do this is to take a look over here at the table. Okay, they did the exact same thing in the table, but instead of using the ratio setup, they just set it up and used the idea of equivalent ratios where they multiplied both the top row and the bottom row by the same things to make them equivalent. Now go ahead and do the try it problem. Try that on your own. Pause the video while you do that and then come back and check your answer. All right, so go ahead and take a moment and take a look at the work. First thing I did was set up a ratio of 15,000 square feet in 3/4 of an hour, and then I went for the unit rate. So the unit rate would be to multiply both parts of that ratio by the reciprocal fraction, which is 4/3. And when you do 3/4 times 4/3, you get 12/12. So the denominator ends up being 1/2. That's this part right here. But since I did that to the denominator, I also have to do it in the numerator. So 15,000 times 4/3 would be equivalent to 15,000 times 4, you can see here, divided by 3. Well, 15,000 times 4 is 60,000, and 60,000 divided by 3 is the 20,000 that you see here. So Daniel can mow 20,000 square feet in 1 hour, whereas Bronwyn only mows 18,000 square feet in an hour. So that means that Daniel mows faster. He can cover more ground in the exact same amount of time. Let's take a look now at example 3. Omar knows that his friend Chris lives 3/5 of a mile away. How far is the school from his house? Well, according to the map, the distance between Chris's house and Omar's house is 3/4 of an inch, but Omar knows that that distance is actually 3/5 of a mile. Okay? What we want to know is the school to Omar's house. So I want this distance here that is equivalent to those 2 inches. So the idea behind this is to use our unit rates in order to figure out what is the map scale, and then use that map scale to determine how far Omar's house is from the school. So in this unit rate here, or in the initial rate, to find the unit rate, we have 3/5 of a mile is equivalent to 3/4 of an inch. You can see the map distance is the 3/4 of an inch, but the actual mileage is 3/5 of a mile. So in order to do that, you are going to divide both parts by 3/4, which is what we just talked about a minute ago, multiplying by that reciprocal fraction, and you would get 12/12, which is equivalent to 1/2. But since you multiply the denominator by 4/3, you're also going to do the same thing in the numerator fraction. And keep in mind, if you've forgotten your fraction computation, 3/5 times 4/3 is equivalent to 12/15, which is equivalent to 4/5. So what that means is that 4/5 of a mile in actual distance is the same as 1 inch on the map. So in order to find the distance between Omar's house and the school, we have to double that. We need the distance for 2 inches. So 4/5 times 2 is 8/5, and 8/5 will simplify to 1 3/5 miles. So the distance there is 1 3/5 mile in actual distance. Now I want you to try the try it problem here at the bottom of page 171 and come back and check your answer. All right, in this problem we're looking for the distance between Paige's house and the mall, which on the map shows at 3.5 centimeters. So the first thing that I did is I set up the ratio that tells me about the distance between Sonoma's house and Paige's house, and I found the unit rate, so I have the map scale. That's what this is right here. That's this 6 miles and 1 centimeter. But that doesn't give me my answer because now I need to know how far 3.5 centimeters would be on that same map. So what I did is I went ahead and multiplied both parts of that map scale, 6 miles to 1 centimeter. I multiplied that by 3.5 to see how far that would be in actual distance. And what I found is that distance would be 21 miles. Here's my 21 miles there on the actual roadways. So if you want to know how I did the 6 miles times 3.5, you can see that right here. There's that work to help you get through the multiplication. All right, so here's our key concept. Remember that if you are looking to find that unit rate, the easiest way to do that when you have fractions involved is to multiply by that reciprocal fraction, okay? Whatever's in the denominator, use its reciprocal in order to get that unit rate. That reciprocal fraction will always produce a product equal to 1 whole. All right, go ahead and try 7, 8, 9, and 10 on your practice and problem solving page, just those 4, and then come back and check your answers, and then I'll give you your assignment. All right, go ahead and take a few minutes, check your answers, and pause the video while you do that, and then we'll be ready to go on to the last one. All right, I promise this is the last one. I forgot about number 14 on the back side of that page. So last question, take a look at number 14. See if you can find the unit rate of miles per gallon for each of those vehicles, the blue car and the silver car, and answer the 3 questions that go with that. And when you're done, come back and check your answer. All right, so you might want to pause the video and check your work and check your answers, see if there's anything that you need to fix or correct. Make sure that you understand how we changed each of those miles and gallons into the unit rates of miles per gallon, or MPG. And when you are finished, you may proceed to your assignment. If you have questions, make sure that you ask.